A cast iron beam 40 mm wide and 80 mm deep is placed on supports 1.25 meters apart and is subjected to a central point load 30,000 Newton. If the central deflection is found to be 6.5 mm, find the value of the Young's modulus for the material. So here we given a cast iron beam 40 mm wide, so width of the beam. So let us note down the given data. Width of the beam. So here width of the beam B is equals to 40 mm and 80 mm deep means depth of the beam. Depth of the beam D equal to 80 mm. This beam is placed on supports 1.25 meters apart, means given length of the beam. Length of the beam L is equal to 1.25 meters. So convert 1.25 meters into millimeters. So we know that 1 meter equal to 1000 mm. So 1.25 meters means 1.25 into 1000 mm. So 1250 mm millimeters. L equal to 1250 millimeters. And this beam is subjected to a point load at center, say. So there is a cast iron beam placed on supports, and these two supports are at a distance of 1.25 meters. Okay, nothing but L, length of the beam. And also given that this beam is subjected to a central load. Okay, no? So a point load at center. Central load means point load at the center. Okay, so that load is W equal to how much? Point load how much you given? So 30,000 Newton. Okay, so point load at center. Okay, W equal to 30,000 Newton. And deflection, central deflection how much? Deflection Y. So due to this point load there will be a deflection, central deflection. So the deflection denoted by Y. Y is equal to how much? 6.5 mm. 6.5 mm. So in this problem we have to find Young's modulus. So we need Young's modulus. Young's modulus is equal to question mark. Okay, so this is according to given problem. Here a simply supported beam is subjected to point load at center. In case of simply supported beam subjected to point load at center, maximum deflection formula is what? Maximum deflection at center. Maximum deflection Y equal to formula WL cube by 48 EI. WL cube by 48 EI. So this is formula is valid for simply supported beam subjected to central point load or point load at center. Okay, so substitute all values, and here I means what? Moment of inertia. In case of simply supported beam with rectangular cross section, moment of inertia I equal to BD cube by 12. BD cube by 12. So B means what? Here B how much? 40. D cube 80 cube by 12. Okay, now let us substitute all values in this formula. Before that, here Y is equal to WL cube by 48 EA. Here only unknown is E. We need Young's modulus. So this formula can be rewritten as E is equal to WL cube by, just replace the positions of Y and E. You will get 48 YI. Now substitute W how much? 30,000 into L cube 1250 whole cube by 48 into y 6.5, moment of inertia 40 into 80 whole cube by 12. So 12 ones are 12 fours are. Right, remaining terms as it is. 3 into, how many zeros? 4 zeros means 10 to the power of 4 into 1250 whole cube by 4 into 6.5 or 6.5 into 4 into 40 into 80 whole cube. See, numerator we have 1250 whole cube, denominator 80 cube. So let it, to make easier calculation, say 3 into 10 power 4 by 440s are 160. 160 into 6.5 into 1250 whole cube 80 by 80 whole cube. It can be written as 1250 by 80 whole cube. 0 0 cancel. 3 into 10 to the power of 4 by 160 into 6.5 1040 into 125 by 8 whole cube. So if you simplify further, E is equals to 3 into 10 to the power of 4 by 1040 into 125 by 8 whole cube. Its value is around approximately 3814.7. Okay. Now if you multiply 3 into 3814.7, its value is 11,444.1 into 10 to the power of 4 divided by 1040. Okay. Now simplify further. E equal to 11,444.1 by 1040 value 11.00, approximate value I am writing 0039 into 10 power 4. Okay. So it can be written as, now move decimal point one place to the left. Now it becomes approximately 1.1 into 10 into 10 power 4. 10 into 10 power 4 means E is equals to 1.1 into 10 to the power of 5. Units Newton per mm square. Therefore Young's modulus or modulus of elasticity of the given material is 1.1 into 10 to the power of 5 Newton per mm square. This is the final answer.